Sometimes hearing about scientific discoveries sounds like magic. The knowledge of thousands of years of testing and learning have allowed us to discover things that previous generations could never have dreamed of. From the unfathomably small world of quarks to the unfathomably large edges of our observable universe, there are some incredible things. And today I'd like to pull back the curtain on one scientific instrument which is able to measure the masses of atoms and molecules, the mass spectrometer, or MS. If you're a chemistry student, you'll certainly encounter this if you haven't already. And if you aren't a chemistry student, I believe this will still be useful to you as if as you might take a chemistry class, and even if you don't, just as a citizen, the whole point of science is to not blindly trust. And so I think it is still good information. And I'm currently in the second semester of my chemistry degree, and I've learned about MS in classes like organic chemistry and chemical equilibrium and analysis, but I've also done further research into things like the history of MS in order to share with you today. The mass spectrometer measures the mass of atoms and molecules and was invented in the late 1800s. And today I will give you more details about that, about how J.J. Thomson was and other scientists created and expanded the field of MS, then explain how and why molecules and atoms are turned into ions before they can be analyzed, and finally, exactly how the mass is analyzed in an MS. First, we have to go back to over 100 years ago when the atom was not fully understood. MS was invented by J.J. Thomson in the late 1800s and has since developed into the modern age. According to Jennifer Griffiths, in the late 1800s, there was a lot of debate about whether cathode rays, which we now know to be electrons, were particles or waves. And people like J.J. Thomson, who believed they were particles, were trying to figure out how to measure the mass in order to prove that. And with the help of Everett, J.J. Thomson succeeded in creating that instrument, which used magnets in order to find the mass of electrons. And this was in 1897. And then later, with the help of Francis Aston, J.J. Thomson created a similar instrument that measured the mass of molecules and of atoms, which was the first mass spectrometer. And then in the 1940s, Alfred Neer used MS for things like figuring out what type of uranium splits, which allowed for the creation of things like the uranium bomb or nuclear power plants. And his work in the field made it a lot more popular. Then the work of scientists like Fred McLafferty, Klaus Biemann, and Carl Djerassi helped scientists understand how MS could be used to figure out the structures of unknown molecules. And then in 1988, there were ionization techniques, which I'll explain what that means later, such as electrospray or MALDI, that allowed for the analysis of heavier molecules such as proteins, which made it a lot more useful in fields like biology. And then according to Melissa Mayer, the Orbitrap was invented in 2005 by Alexander Makarov, and it is a relatively small machine, still fairly big, that can measure the mass of molecules very precisely. It is what is known as a high-resolution mass spectrometer. Now, how does such a powerful and influential machine actually work? Well, it starts by turning atoms and molecules into ions. But first, let's talk about atoms. Atoms are made up of three particles. The proton, which is a positively charged particle, and then the neutron, which has no charge, and then the electron, which has a -1 charge. Now, the protons and neutrons make up the very tightly packed nucleus of the atom, and then the electrons exist around the nucleus and are attracted to the protons. And then molecules are made up of groups of atoms where they are bonded together, and the bonds are made up of electrons. Now, atoms and molecules often have equal numbers of protons and electrons, which means that overall they have no charge. However, in mass spectrometry, we want to control them using magnets, which requires that they have a charge. So we want to turn them into ions. And ions are atoms or molecules where the protons are not the same in number as the electrons. You can see here we have like an added electron, and here we have one taken away. And once you've done that, they have an overall charge and can be controlled by magnets. And one common method to do this in mass spectrometry is called electron impact ionization, where you have a beam of electrons that is shot at your sample, thus knocking off other electrons and actually giving a positive charge. And now that they're ionized, they can be controlled by magnets, and you can then analyze their mass using things like magnetic sector and time of flight, MS. So one relatively simple way of measuring their mass is called magnetic sector, which, according to John McMurray in his textbook about organic chemistry, shoots ions into a bent tube with magnets that redirect them. And the lighter molecules are going to be redirected more, whereas the heavier molecules are going to be redirected less by the magnets. And you can then detect that at the other end in order to figure out the mass. However, I should note a technicality. If you have a higher charged molecule, it will bend proportionately more in the magnetic field, which means that in reality, what an MS measures is the mass to charge ratio, or the m/z. However, for small molecules, after ionization, they typically have just a +1 charge, which means that it's effectively just measuring the mass. With that said, another method is called time of flight mass spectrometry. And in time of flight, you shoot a packet of ions into a tube, and the tube is straight if it's a simpler type of time of flight. And this packet of ions, it will then separate based off of the mass, because the heavier ions are going to move a lot slower versus the lighter ions that are going to move a lot faster. And thus, you can use the time of flight to figure out the mass of all the molecules. And again, note that higher charged molecules are going to be propelled faster, and thus it's still technically just measuring the m/z. Now, there are so many more ways to make an MS, and the history of it is still evolving, but all of that requires chemistry knowledge that even I don't fully possess. So, MS started as a way to find the electron in the late 1800s by J.J. Thomson, and it starts with ionizing molecules or atoms and then passing it through a tube that uses magnets in order to find the mass to charge ratio. And that is the history and function of an MS. I hope that now you can more fully appreciate scientific discoveries that humans have made, and maybe you'll want to take a chemistry class or two to unravel more mysteries that science holds. Thank you.